So this is a new idea. It has to do with social physics. It's doesn't seem like a very profound idea. It's the conclusion is fairly obvious once you accept the initial premise. And the premise that I am going to work with is to assume that in a society where you imagine that you have a neighborhood and lots of families are living next to each other. And so we are going to be looking at neighborhoods like this, different kinds of neighborhoods. And let's say that in a given neighborhood, in a given home, there is a family, and we'll consider that family to be a bound state. So we'll consider a family to be a bound state, consisting of whoever the people are living in that home. And for the time being, we will not worry about such things as changes in the size of the family. We will assume that we are looking at a quasi-static case, uh, or that in this particular society, for instance, um, people are not too prone to leave their families. So it's possible that once you weaken this assumption, uh, the conclusions that I'm going to talk about uh, might change. So what we have here is we have a quasi-static situation where you have very tight family groups. They're living next to each other. And this is, of course, not a very bad approximation of reality at all when you consider, for instance, East Asian cultures. Uh, and, till some time back, in many places of India, even now, you have very tight family groups and entire neighborhoods of such families living together side by side. So now, once you have made this sort of particle-like picture of your system, then you can ask what will happen if one one family out of the many in the neighborhood suddenly gains a lot of energy. So in this case, in the social situation, one could imagine that you have a family which wins a lottery, and a cash lottery, and they uh, suddenly overnight they go from being the average, the same as everybody around them, to being very, very wealthy. Now, what we know, there are two different things. One is the expected social behaviors, which we expect to see due to this change. And the second is that what would we expect the long-term state of the neighborhood to be, of this neighborhood, let's say, if, for instance, not just one family, but several families in the neighborhood, some fraction of the total number, won this cash lottery. So let's say you have 15 houses in the neighborhood, and maybe like about 5 or 7 of them have won the lottery. So the next morning, the people who have not won the lottery suddenly wake up to find themselves much less wealthy than their neighbors, their very lucky neighbors. So one can ask the kind of obvious question, that what will be the state of the neighborhood sometime in the future, which is long enough for everything to settle down and return to an equilibrium. Because remember, we started from an equilibrium state, and I suppose that was implicit in the assumptions and the statements that I made about everybody living peacefully together. So that assumes that there is a social equilibrium. And by introducing a certain large amount of income inequality, what we have done is we have created a massive non-equilibrium situation. And so this non-equilibrium will obviously not be stable. And unless there is a constant injection of wealth into the families or into the neighborhood, uh, the what will be the likely state of the neighborhood after a long time? Now we need to be very careful about referring to a notion of equilibrium in the context of something like a society of humans or living organisms. The very important reason for this is that such systems are necessarily dissipative. And arguably, one could say that Jeremy England, the famous British theoretical physicist, has shown that that is what leads to the formation of complexity in physical systems, and it is the continual transmission of energy through a system which leads that system to self-organize in such a way as to allow that energy to flow through it, through that system, as easily as possible. So we're going to adopt this perspective of all the systems that we deal with, that they are all dissipative and that they are all, from one perspective, one would call it a non-equilibrium situation, because that's what we do in physics whenever we have a system with a flux of energy through it. But here we want to define a notion of equilibrium, which means that the system stays in the same quasi-static state. A simple analogy of such a quasi-static state uh, would be, for instance, a pool of water in some mountainous valley, which is being fed uh, by a spring from the mountains higher up, and then there is also some outflow from that lake onto further rivers and water systems. So now, if that lake is large enough, then one would technically say that yes, it's a non-equilibrium system because there's a non-zero flux of energy through its boundary. But but for the residents of that lake, let's say the uh, sea creatures which live in that lake, in the center of that lake, will not notice a change in their surroundings, a rapid enough change in their surroundings for them to adjust their own behavior. So this would be an example of a quasi-static system. Even though it has a continual energy flux through its boundary, both influx and outflow, the majority of the system, in the majority of the system, the different parts of the system, the inhabitants there, do not perceive the system to go through any rapid non-equilibrium changes. Now, obviously, uh, this notion of non-equilibrium is far too strong because we're talking about family units, and at most they're composed of 4 to 5 members, or something between 2 and 10, like let's say, is a safe conservative range for family size. And so obviously in this case, when you have a system with only a handful of particles, you have to be more careful with the definition of any notion of a quasi-static state. Now, this is already becoming a very long uh, discussion, and so I just want to state the basic conclusion, the picture that I have in mind for what happens at the end of the day. I heard somewhere that, if you want to make a good movie, or if you want to write a good story, you should start at the ending. So here is the ending that I have in mind. uh, for this particular story. And this ending is an understanding of what leads to the formation of economically segregated neighborhoods. In other words, what is the original, how can we understand uh, why human beings uh, separate, segregate themselves, physically segregate themselves, right? So there is an emergent, there, well, okay, I shouldn't use the word emergent because it's the most overused, overhyped word. So, but there are behaviors which lead to segregation of what was previously homogeneous society in some again quasi-static state. And the notion is that the injection of inequality into the system, and not just at for a given instant of time, but for sustained durations, for months or years or decades. So that means that there are some people who keep getting richer, and the gap between the rich and the poor keeps growing. And there can be more than one such gap, right? But we will just stick with the simple example of there being a single wealth gap. And so it is that wealth gap which was present initially, which was created initially and then maintained over time, leads to the formation of, leads to people uh, who are uh, financially more um, compatible, let's say, with somebody else, to pair off with such people and to end up inhabiting a place where they're surrounded by others like them. So here, the basic cause of segregation is two things. The first is the injection of inequality into a previously homogeneous quasi-static system. And then the second is that, so this is an assumption about human behavior, which may turn out to be incorrect. But the assumption is that humans tend to cluster around those who are similar to them. And this tendency provides the motive, the force, uh, and given the initial conditions, the inequality, uh, the motive force which drives all humans, which is this desire to find others like us and to stay with them or in their vicinity. uh, this is what leads to physical segregation along economic lines. Now, one could argue that all of this is sounds very elegant and very beautiful, uh, but how do we know that it actually has any relevance to real life? How can we ever do that, right? Because we can't set up. We can definitely run agent-based models in computers and at very large scales also. Uh, but of course, the best way to understand the efficacy of the theory or the picture presented would be to have real social data. And since it would be unethical to ask people to volunteer themselves or a portion of their lives for the purposes of such a social experiment, uh, it becomes challenging uh, to verify this theory. But what I expect to happen is that it will probably turn out to be the case that some or the other government or municipality or other form of, democracy, in whether in a democracy or um, a non-democratic society, in some place somewhere, such an experiment must already have happened. And maybe, if not an experiment exactly like the one that I described, but something along these general lines. Uh, and then, because of the zealousness of the believers who that society was unfortunate enough to have as the leaders at that time, that experiment would be repeated over and over again. Because, as Einstein said, that doing the same thing over and over, and when you know that, and failing is the definition of insanity. So I expect that there is already data out there, either which has been taken or which is waiting to be measured, and which can be used to either confirm or refute the model that I have presented.